hello everyone who's joined and welcome to today's STEM Plus X webinar. My name is Kimberly Valeni and I will be your moderator for today. Since graduating from QUT, I've been working as a front-end developer at Deloitte Digital, where I create websites and mobile apps for big clients and small ones too. I'm super excited to also be working with the careerswithstem.com team to bring these webinar events to life. It's my passion to inspire more young Australians, especially females, to explore careers in STEM. Before we start, I'd like to acknowledge the Turrbal and Yagara people as the First Nation owners of the lands where QUT now stands, and all of the lands we are joining from today. I acknowledge our First Nations people as the original STEM innovators and traditional owners of Australia, and I pay my respects to their elders past, present, and emerging. If you're joining us live, welcome. Please get your questions ready for us and tell us where you're joining from in the chat if you haven't already. Today, we have an awesome lineup of impressive science professionals who have combined their love of science with their X, which is their passion, a problem they're trying to solve, or another discipline. You'll hear more about our STEM plus X formula later on. The panelists are standing by to share their career paths and answer your questions. And if you're watching this from the Careers with STEM YouTube channel, thank you for tuning in and don't forget to subscribe. All right, in this webinar, we're celebrating the latest issue of the Careers with STEM magazine, the science issue with a special section on the environment. This was delivered to Australian high schools in early February 2023, so be sure to look out for your copy. If you didn't get it, you can check out the digital or e-edition at careerswithstem.com. Careers with STEM is a one-stop inspiration hub for high school students about careers in STEM, which are growing twice as fast as non-STEM jobs and are found in every sector. In the pages of this bright, fun magazine, you'll meet real-life career role models, showcasing the range of exciting and sometimes surprising career paths available in science. You'll also find out who the employers are, their starting salaries, and some of the projects that will need your STEM skills. Whether you're passionate about helping the environment, curing disease, understanding ancient worlds, or working with cutting-edge tech, there could be a career in science out there for you. The exciting part about STEM skills is that there will be careers in 5 years' time that don't even exist yet today, so your opportunities really are endless. Today's webinar is brought to you thanks to our sponsor, the Queensland University of Technology. Also known as QUT, it's a university that I can definitely vouch for because that's where I studied. I graduated at the end of 2021 with a double degree in information technology and creative industries with majors in computer science and interactive and visual design. QUT is known as the university for the real world because of the approach of embedding real-world learning into their courses, as well as linking students to real-world projects through work-integrated learning initiatives. Before we meet our panel and explore their careers, we wanted to share Careers with STEM's secret formula. We call it STEM plus X, where X is your passion, an interest, another subject, a big opportunity, or a life-changing goal. Think tech plus agriculture equals smarter farming, or science plus business equals new space rockets, or engineering plus health equals new medicines, and maths plus shopping equals happier customers and less retail waste. Take myself as an example. My personal STEM plus X formula is technology plus design, which is definitely the reason why I studied my double degree of computer science and interaction design at QUT. STEM plus X can lead you to some surprising careers today and into the future. So in today's webinar, you'll meet 3 amazing STEM professionals who have combined science plus X, carving out super interesting careers in science. You'll meet Dr. Michael Cowley, who combined science plus space. He's an astrophysicist who specialises in galaxy evolution and supermassive black holes. We also have Lauren Fell, who is also science plus space, who combined business plus psychology to create an amazing startup. She's a space entrepreneur who is experimenting with growing plants on the moon. And lastly, we'll chat to Brett Lewis, who is science plus environment. He's an Earth and atmospheric scientist who's imaging, monitoring, and saving our coral. Once you've heard from our panelists today, you might be inspired to find out more about combining science at QUT with your X for an amazing career. More information can be found at qut.edu.au/science. Alrighty, let's get on to our first panelist. So Dr. Michael Cowley is an astrophysicist and a lecturer at Queensland University of Technology and an adjunct research fellow at the University of Southern Queensland. Welcome, Michael. Can you tell us a bit about yourself and what an astrophysicist does?
Yes, thank you for having me. It's a pleasure to be here and welcome to everyone there. As mentioned, I'm an astrophysicist and lecturer at QUT, which is on the lands of the Turrbal and Yuggera peoples in southeast Queensland. Now, I've got a fairly unique role and has lots of complex areas, but I guess the gist of it is it's researching galaxies and supermassive black holes and to pass this knowledge and the knowledge of those before me onto the next generation of astronomers. And that kind of encapsulates everything from being a researcher and a lecturer as well.
Perfect.
Now, yeah, please.
I was just going to ask, for those who might not know, like myself, what really is a black hole and how are they made?
Yeah, look, good question. Black holes are regions of space-time that are extremely dense and they have a gravitational pull that is so strong that not even light can escape once it passes something known as the event horizon, which is a critical threshold. Now, these black holes, they come in a range of sizes. There's small ones that come from the collapse of individual stars. There's supermassive ones that exist in the center of most, if not all, massive galaxies, including our own Milky Way. These supermassive ones, mind you, they can be on a scale that are millions to billions of times more massive than our own sun. And they also have the potential to impact their galaxy as well. They could potentially impact the evolution of the galaxy, including our own Milky Way. And so it's important for scientists to study these objects, these exotic objects, to see how they could potentially influence how our galaxy has come to be and where it might be going in the future. And I think most would agree with me that just studying black holes in general is, some of the most fascinating and mysterious objects in the universe. And it provides great insights into the nature of gravity, the structure of the universe, the evolution of galaxies, and probably something a little bit far out there, but to link it back to QUT for the real world, is the fact that black holes are believed to be the most efficient process of converting matter into energy. And so perhaps important to our very way of life in the future as well. So who knows, your next iPhone, or maybe not the next one, but maybe in 50, 100 years' time, your iPhone will be powered by little mini black holes. It's a daunting thought, but, who knows?
Yeah, I guess we'll have to see. So it sounds like black holes have been here for a long time and will be for quite a while. What cultural understandings of astronomy have been applied and developed by Indigenous peoples?
Yeah, look, I'm an advocate for incorporating Indigenous perspectives into education. I'm currently an associate fellow for the Higher Education Academy, specialising in Indigenous astronomy education. And it's important to incorporate Indigenous concepts of astronomy into our education and into our research, because the Australian Indigenous peoples, they've developed a rich cultural understanding of astronomy, which is based on their deep connections to the land and to the sky. And these understandings, they've passed them down for generations to generations as well, using oral traditions, ceremonies, their rock art, and they've done that for tens of thousands of years. Perhaps one important aspect of Indigenous astronomy is the use of the night sky for navigation. For example, I know the Waterman people of Northern Territory use the position of the stars to navigate across their traditional lands. Another example is the use of the sky for seasonal and agricultural calendars. Many groups, for example, have used the position of the stars and the moon to mark a changing of the seasons and to determine the best times for hunting, gathering, planting crops, harvesting crops, and even their social ceremonies as well. Look, Indeed, the Indigenous Australians have developed a complex and sophisticated understanding of astronomy. And given the fact that most astronomy classes and even textbooks in this area usually omit this knowledge, it's quite criminal. So I've made it a goal of mine to try and rectify this and incorporate it into our modern understanding, so we don't give the credit to all the ancient Greeks when it comes to the history of astronomy.
Yeah, that's super inspiring. And I guess it's another X to your formula of STEM plus X of including that perspective. So you started out actually as a finance analyst in a bank, which is as far from black holes as you can be. How did you make that transition? And are there skills that you can use in both science and banking?
Yeah, it's a good question. So I started off in corporate finance, did that for about 10 years. And I felt that I was never quite fulfilled in my job. And I started investigating options to take some of the knowledge that I'd picked up in the finance industry, namely numbers and number crunching and a bit of coding as well, and see if I could apply that into something a little bit more interesting. Now, I won't say that I was the cause of the global financial crisis, but I certainly played a role in it. And so I was quite happy to escape that field and jump into some other area, namely fundamental science in the form of astrophysics. And so I didn't necessarily have an interest in that space before then, but it appealed to me as something quite different and something I could potentially leverage my existing skills into. And so even though I'd say, leaving from school and jumping into STEM is the best path for our mature-aged students out there, it's certainly a possibility as well. And so I joined university and brought over those skills. I think the most important one for me was time management skills, because it's always going to be a challenge transitioning into university life. And from there, I was able to complete an undergraduate degree in physics and astrophysics. Eventually went on and did some postgraduate study before becoming a PhD, and then eventually all the way to the present where I am as a researcher and lecturer today.
The massive education phase, and that's really inspiring. Taking a step back from, I guess, doing a bachelor's degree, what do you think are the subjects in high school that are essential if someone's interested in being an astrophysicist?
Yeah, so you're exactly right. A master's or a doctoral degree in astrophysics is typically required to become an astrophysicist, but the good news is there's a starting point, and I recommend starting with the basics. So study science, physics, mathematics, and astronomy at school and even undergraduate university. That gives you the solid understanding of the fundamental concepts in the field. Astrophysics is highly multidisciplinary. I need to understand the chemistry of what goes on inside of the sun. I need to understand the particle physics nature of light. I need to understand how light is captured by instruments such as telescopes. I need to understand IT and mathematical components to run universe simulations on my high performance or supercomputers here at the university. And so getting just all of that fundamental STEM, all of it, it's going to pay off in dividends by the time that you start to get that hands-on experience. And speaking of the hands-on experience, start volunteering at local planetariums or your astronomy groups. I know that where I live out at the Redlands in Southeast Queensland, they have a Redlands astronomy group. I know there are plenty out there. And look, at the very least, if you don't have one nearby, start by observing the night sky in your backyard. Get a cheap telescope, some binoculars, even your own 2 eyeballs. Keep a record of your observations, learn the constellations, the movement of celestial bodies. It's an awesome first exercise to kick things off, and you'll give yourself quite an advantage by the time you make your way into university.
That's fantastic. And we'll give you one more question before we wrap up. It's a question from Kim in the chat for you. What advice can you give to what advice can be given to year 10 students who want to gain some real or virtual work experience in the field of astrophysics?
Yeah, look, great question. Like I mentioned, perhaps see if you can volunteer at a planetarium in your area, join that astronomy group. But if you're thinking about from a virtual perspective as well, there's tons of activities online that are offered through the general places that you can think of, like NASA or CSIRO, Australia's Science Institute. And they've got plenty of resources for the budding astronomers that are out there that are interested in the field. And some of those activities will be computer-based, others will be hands-on, so print them out and do them. Like I mentioned before, tracking the constellations or the movement of celestial bodies through the night sky. I base that on an activity that I stole from the CSIRO that I usually give out to school students when I go and visit the school as well. I've got other ones that I've stolen from NASA, which is tracking the movement of the moon as well by taking photos each night of the moon against the backdrop of the night stars. So there's stuff that you can do with the equipment that you've got on hand, and no matter your location in the world as well. If you've got a little bit of internet access, library access, something like that, I'm sure you can find tons of resources out there. So good luck.
Perfect. Well, thanks so much for your time, Michael. We'll pop you back into like a big room for more questions afterwards. But for now, I'd like to move on to Lauren Fell. Lauren is a director of Lunaria One, an Australian space startup which has a goal of growing plants on the moon. She's also an associate lecturer and PhD student at QUT and is researching experimental protocols to test quantum-based models of cognition in human trust judgments. It's a bit of a tongue twister, Lauren, and it sounds pretty complex. Could you break it down for us just a bit more?
Certainly. So yeah, I'll start with the PhD. I essentially, my favorite way to explain this is, you've got the classical world. We see, apples falling from trees and all this that you might be familiar with, this Newtonian physics that makes a lot of sense. But the problem is this doesn't really work the same way on a really, really small scale with small particles. So things act weirdly. I don't know if you've ever heard of Schrodinger's cat, where it's both alive and dead when it's inside a box. This is this idea of superposition. There's other things like you can't be certain of a particle's position and momentum at the same time. You can either know one or the other. So these sort of things are a little counterintuitive, but that's how the very small scale world works. In a similar way, our minds, we have this idea of logic and reasoning and sort of logical thinking, rational thinking, but often as humans we don't engage in very rational thinking. We have biases, cognitive biases. We work with heuristics and that kind of thing, and we tend to violate these laws of rationality or classical ways of thinking. So actually it turns out that putting these two things together can actually work quite nicely. So just the I guess the mathematics behind the quantum kind of realm, these tiny particles, the way they work, things like superposition, concepts like that can actually be applied to how we think in an intuitive way. So for instance, superposition, a cat being alive and dead at the same time, we can also be in two minds at the same time. You can both want pizza and pad thai at the same time, and so the probability that you choose one or the other can actually be modeled quite nicely from the models that we use from quantum physics. So that's my PhD. I'm sort of looking at actually modeling this in the particular topic area of trust and how we make trust decisions, because that tends to be quite an intuitive process and we're not always very rational when we make these sort of decisions.
Yeah, well.
So that's my PhD. I also teach, I lecture in the Masters of IT program. My background's in psychology, so I actually focus on the human side of IT. I've done a bit of UX in my background as well. And then on the side, while I'm doing these sort of things, I also a few years ago just engaged in some NASA challenges. So Michael was mentioning these sort of things that NASA and other agencies set up to invite everyday people to be involved in the science and the engineering. These are the sort of things that NASA sets up, and it's just it's called crowdsourced innovation. So it's sort of citizen science, it's sort of challenge based, and anyone can enter, and you just put forward an idea, and if it's it's judged as being worthwhile, then you can win these things. And so I won a few of those, and through that sort of pushed me down this journey of in space in that sector, which has led me to lead a project now to put some plants on the moon in 2025. So we're really underway now, and I'm not a biologist or an engineer, and those are the two main components of this. So I'm learning a lot as I go. It's very fun. And yeah, at the moment, our biologists here at QUT, as well as internationally, are selecting some very specific plants and seeds that can go up there. And I'm also leading a sort of education campaign and outreach to get people involved, because I am really passionate, having come from a background of participating in citizen science and this kind of thing. I'm also want to get as many people involved in this project as possible. So school age to university to anyone who wants to sort of try out their sort of experiments of seeds in their backyard.
That's so fascinating. Thank you so much, Lauren. It's surprising to hear about all the links between the way that we think and quantum physics, and it's just things I've never considered. Now, you mentioned growing plants on the moon, which to me sounds bizarre. What will it mean when we can grow plants on the moon? Because 2025 is not that far off.
Yes. So this is probably a little bit of a misleading image I've got here. We're not planting them directly in what's called the regolith at the moment, the soil. We're sending a little capsule. So it's kind of first steps. So we just first need to figure out what effect the different radiation environment, as well as the conditions of the trip there and the conditions on the moon is going to have on the plants that we send up. So it's going to be a very small, like tin can sort of sized capsule with a little camera, some other equipment to sort of sense how these are growing. And we've got, at the moment, we're selecting some seeds that are going to be hardy, so they can, essentially there's going to be a big temperature swings. So you tend to find plants that are either really good in cold conditions or really good in hot conditions. And within those, you've got a subset of ones that can survive long periods without water, that kind of thing. But it's rarer to find ones that can survive the swings in temperature that we're going to experience there. So we're selecting a few of those. We've also got some specialists here at QUT that are looking at resurrection species. So there's a native grass species, for instance, that can be totally dehydrated. It looks like completely dead grass. And as soon as you introduce water, it just springs to life, not only growing new shoots, but actually the dead parts become green again, which also has some excellent spin-offs in anti-aging and sort of cell repair and this kind of thing. So there's a whole lot of science that's going on there as well, which is interesting. But of course, real world, applications of this kind of experiment. Of course, it's a very small first steps kind of experiment to sort of one day have a habitat on the moon. But also we learn a lot of lessons of finding species and being able to protect plants from very harsh conditions, which of course is becoming increasingly important here on Earth as the temperature and the climate is changing.
Oh, wow. That's so exciting. Now, you mentioned that you have a background in psychology, right? On top of everything that your brain's going on. How has your background in psychology and working in mental health helped you with your work?
Yeah, so I see psychology as one of those degrees that kind of applies everywhere. Anytime, any job you have, you will eventually have to deal with people and understand people. Whether you go into business, you need to understand customers and stakeholders. If you go into science, you need to be able to communicate really well and collaborate and work with people, engineering, even IT, which I try and teach my students. So it helps not only to sort of understand the psychological parts of what I currently do, so things in the education space and, obviously the quantum cognition stuff, but also, being able to understand how to work best in a team, how to, construct convincing arguments when you go into academia. There's a lot, and as well as in startups, getting funding and sort of writing proposals is a really important thing, and being able to understand the person who's receiving a proposal and try and speak to that is a really useful skill. And I find that my psychology degree has helped there. So yeah, many aspects. Understanding humans is a really important thing to have. So that's helped a lot.
Yeah, it sounds like it's a great foundation across everything else that you do. So perfect. I might leave you with one more question that is from Jade from the chat. Jade asks, is your work or the work of Lunaria One the kind of thing that can be done remotely or hybrid?
Certainly. So our team is currently across Australia and across the world. So we do actually have to do it very remotely. My main partner in this initiative, I've never actually met in person. You know, we started sort of during COVID, so you know, it's often started very remotely. Eventually, of course, we've got to physically create something and then physically take it to where the lander is, so that it can be integrated. So there's certain parts obviously will need to be done face to face, but yeah, a lot of things these days, it actually is conducive to remote work, and not ideal. It's much better, and you generate ideas in a better way, I think, by physically being with someone, writing things down on a board, being in a physical space. But certainly it's possible to do remotely.
Yeah, and it's flexible, which I think is the big selling point. Wow.
Yeah.
Well, thanks so much for your insights, Lauren. Super fascinating. And we'd love to hear more from you towards the end of this webinar. With the time we have left, I'd like to invite up Brett Lewis to join us. So Brett is a postdoctoral researcher at QUT's Earth and Atmospheric Science Centre, where he studies coral biology, behaviour and adaptation using high resolution 2D and 3D microscopy, videography and model development. Also a tongue twister, Brett. He's filmed for the BBC, and his imagery and videos have featured in over a dozen documentaries, which have won loads of awards. Welcome to the webinar, Brett, and thanks for being a panelist. Could you tell us a bit more about what you're working on now?
Hi, everyone. Yeah, I can tell you more. First up, how awesome are Michael and Lauren? Their work is so cool. So definitely intimidating to go after them, but I'll do my best. So my work now, I look at, specifically I work in the space of microscopy. So I'm interested in observing coral, seeing how they react, behave to certain environmental changes and factors on both a macro, micro scale. So we want to basically look at, say, if I was looking at a runner, I wanted to look at Usain Bolt, and he was moving, you know, and see how he moves so quickly. Well, we could look at his mechanics, how quickly he moves his, how quickly he moves his legs, how long the strides are. That's what I want to do with coral. But then I want to kind of break it down and start chopping them up and start looking at the cells at those layers to see what underpins those processes. So you can see behind me, this is an attempt at doing that. This is a coral polyp. And so a coral is can be made up of one polyp, or it can be made up of millions. So they are colonial animals, and each one of these polyps is interconnected with another polyp. That's what makes them so productive, is that they work together like a bunch of polyps in an apartment block, and they just grow their apartment block larger and larger, and that's how corals form. But this one here, you can even see the fluorescence of all the individual cells. So this is a 3D render. It's only in 2 dimensions at the moment, but you can see all the individual cells. The red dots are the zooxanthellae. So they are the symbiotic algal cells that live within the tissue and that photosynthesize and give the coral food. You can see the kind of gel-like outer structure of the epidermis around the outside, kind of almost like a ghost membrane around the outside of the tissue there. And then you've got these, which are the stinging cells right here. So like a jellyfish, corals are very much related, and they are like an upside down jellyfish. So they have huge amounts of stinging cells where they trap and paralyze prey and then devour them in this hole behind me here, which is their mouth. So yeah, basically this is what I like to look at. And then once we understand the fundamental biology of coral, we can start to apply it at a larger scale. So in particular at coral reef restoration, where we can start to apply these fundamental understandings of coral in order to understand how they're adapting to climate change, so we can start to change the processes and how we treat those corals.
Wow. My brain can't even register everything that's going on in the image.
Sorry,
and
too
everything
much.
that's nuts, and it's so interesting. So there's a lot of links between like biology from a small scale and going upwards. What kind of new techniques do you think biologists are using today, and what sort of skills do you need to work in conservation? So kind of a 2-in-1 question.
I think honestly, like Michael and Lauren, they covered a lot of that, just any skill. You know, like this here is STEMX, right? So for me, I brought my photography skills into what I do. I understood how to take time lapse, how to take macro images. Then I started to try and understand how the fluorescence worked in the coral, and then everything kept breaking down from there until I got a larger skill set in that area that was more specific to my area. But initially I was targeted during my undergraduate here at QUT by my supervisor because I had a photography background, and he thought that could really apply very well. So, but any skill can work in these spaces. You just have to think about what is your passion and kind of bring it to the science. I wanted to work with sharks and rays. I used to live up on the Great Barrier Reef, and when I was traveling around Australia, I kind of fell in love, and I decided there and then that I'm going to change what I want to do with my life, and I'm going to become a scientist, and I'm going to help protect it and understand it. And I came down here, and 10 years later, I'm doing a postdoc. So it took a while, but yeah. So I just bring your skills, whatever you can think of, to your passions, and you'll be fine. And be open-minded too, because like I said, I wanted to start with rays and sharks, but you know, in the end, I ended up working with corals because that was where I got the opportunity. That's where I got to apply my other passions, and I stayed in it.
Yeah, so it's always interesting to hear that people's passions, sometimes people sacrifice that to pursue their work, when really you can fuse them so well together and kind of not see the intersect between them, right?
Yeah.
So you yourself, you combined technology, geography, and data with studies of the reef. Now, why is that important, and what tech do you think will be critical to future conservation?
Well, so much. So we even had a meeting yesterday about technology that doesn't currently exist. So it was a bit of a wonky meeting because we were trying to work out exactly how we were going to follow up on the next few years worth of research in order to hopefully achieve these goals for this technology that doesn't currently isn't presentable. So, you know, it's really hard to predict what's going to be the next thing. For me, when I'm imaging these, I'm imaging obviously, in some cases I'm imaging by using electron beams or plasma focused ion beams. In some cases we're cutting through the tissue in order to be able to do it. In this case, we're just kind of using the natural fluorescence of the coral to scan through the tissue. What I want to do here, and I think is one of the most challenging issues that we face, both not just with coral, across the biological spectrum at the moment, is creating what we call integrated imaging. So where we take these three-dimensional renders, which these are the first time that we've been able to do this at this scale and resolution for coral. And then we're doing it then at a cellular level and looking at all the insides of the cell, like the nucleus, and being able to 3D render those so we can understand their volume. But not just that, but look at the chemistry at that level and the omics. So what we call omics. So we look at the genealogy, we look at the proteins and the lipids within that space. What is happening? How are those cells functioning? And then if we can do that and we integrate that, we just create a complete 3D map of the cell and how it functions and all the integrated important parts and where that information is coming from in its, whether or not it's the omics or the proteomics or whatever it might be. But that's where I would like to go, is be able to map the biology of coral in 3 dimensions in a way that just, you know, can also function for humans as well, which, you know, I know that's an important area. So yeah, we want to kind of keep pushing the limitation, the boundaries of imaging and what we can do with it.
Yeah, absolutely. I think the opportunities really are endless as technology continues to evolve. Okay, I will leave you with one more question, which is from Jade in the chat. Would you say that networking or making connections had an impact on your direction?
Oh, 100%. Yeah. Look, if for the students out there, if you're coming to university, the most important thing for you to do is surround yourself with really like-minded people. Surround yourself with like-minded people. Find these supervisors and the researchers that are in your area that you're interested in, and reach out to them while you're at uni, or even, you know, if before then is fine too. You know, supervisors and academics are always looking for the next group of students that they want to take on board. So if you show application and look to network yourself, that's a great skill to have. But yeah, for me, networking has been huge. So, you know, I couldn't network with the BBC or, you know, we've worked with 35 different museums and institutions around the world to integrate our imagery and science into them, including a 15-year contract at the National Museum of Australia in Canberra, which will be showcasing our research for the next 15 years, and education portals in Indonesia for the next 20 will be using it. So it's these kind of collaborations are super important, not just for your research, but just building your skill set and, you know, and enjoying your research and enjoying your work as well, I think.
Yeah, absolutely. I always like to say that networking is kind of like a ripple effect. You know, you make one connection and it just kind of continues to spread.
Exactly. Very much
well,
so.
Thank you so much for your insights, Brett. That's super exciting. And I would love to hear more about your career. I'd love to invite back Michael and Lauren to the chat. What an inspiring trio of people that we've just heard from today. Super exciting. We've gone through most of the questions in the chat, but we might give it a minute for it to populate more. In the meantime, I did want to ask all three of you the same question. What is your best piece of advice to your high school self? We might go in the same order, so Michael, then Lauren, then Brett, but what is your best piece of advice to your high school self?
Good question. I'll be rude and I'll give you two. So the first one I think I'd give to myself is, like many people, I think when you're doing a particular subject or a particular problem at school, you might be thinking, when am I going to use this? What am I going to use this calculus for? Or what am I going to use that for? And look, it might be true. You may never go ahead and use that particular element of calculus in your day-to-day life ever again. But the thing is by completing those problems, you gather problem solving and critical thinking skills, which allow you to solve complex problems in so many other areas that you'll no doubt come across in the future. So do your calculus. The other one is I wish I kept more up to date with the latest and developments in, you know, the field that I was interested in. Now, obviously, I took a different path. I didn't go straight from school into STEM. I went from school into finance into STEM. But something that when I was starting off in STEM is I found that was really helpful for me was keeping abreast of the latest breakthroughs, the latest trends, and just looking up that news, looking up the science paper that's associated with it, and just having a general bit of knowledge with it. And then suddenly it broadens your horizon so much. And I've been able to poke my way into so many other areas of science, like some stuff we didn't touch on. I've helped out with lighting physics because an astronomer needs to know about the physics of light. And so I've helped out in industry where I've been able to apply my understanding of light to so many other areas as well. And it's just by poking my way into all these other interesting areas as well. So, you know, keep up with the latest trends, keep up with the latest breakthroughs, and, you know, it'll keep your mind open to all the possibilities of the future as well.
Great. Yeah, some excellent advice there. I'm going to give some maybe a bit anti-advice to that about the calculus, but for me, I probably would tell my younger self, it's okay if you're not great at maths. You can still go into things that require maths. But of course, still push on and try to learn these things. But I think for me, I thought, oh, I'm not good at maths. I can't ever do, quantum physics, or I can't do these or engineering and that kind of thing. But there are so many other pathways and opportunities, and you can, if you're more of a person who learns by doing and by sort of applying real sort of problems, then, you can learn these things as you go. You can sort of learn them when you need them as well. So don't let that discourage you. As well as, don't limit yourself, which is kind of connected to that. Don't think, oh, I can never do that. The only reason I sort of went into the NASA things is because I have this, perhaps silly mindset that I can do everything. Everything's kind of, surely I can do that. So sometimes it means that I spend way too long on a problem that is, probably realistically a little beyond my capabilities. But in doing that, you learn so much, and you really catapult your learning by taking on really, really hard things and not limiting your belief in yourself. So I'd really encourage everyone to you can do anything. It might just take a bit of time.
And Brett?
Going after that, great advice. I would say, for me, if I was, to travel back in time and be able to tell myself, I'd say stay in school. I was a high school dropout. So I didn't have the best education growing up, and I certainly envy the schools here in Brisbane compared to my little country town high school, which certainly doesn't have the kind of resources that are available here. It was a much harder school to go to. So I would have said stay in school, because everything would have been so much easier for me. Every step of the way through my bachelor's and master's and PhD, I've not only been learning how to be a scientist and researcher and communicator and collaborator and team player, I've also been having to learn all my fundamentals again. Just basics of math, basics of English, even now I can't even talk English properly. But I've had to learn those things at a level that is beyond what, the average person would have to do. But I started below that. And so it was very hard to do that. So knowing that, go through school, just pay attention in English and at least math and all those kind of things, and just know that they are going to, like Michael said, it may not help you directly in life, like that you'll be aware of, but those skill sets will absolutely give you the foundation to succeed. And that was the hardest thing, is that my foundation was so low coming into this, and it made it very challenging.
Very great advice from all three of you. Thank you so much. We might wrap this up with just one more question from the chat that I might answer myself, actually, and then we can wrap up the webinar. Jade asks, do we have any advice or thoughts on how she might be able to combine an existing IT resume with biomedical science degree? And I kind of like to think of this question as both the IT and the biomedical science are both STEM related, right? So your STEM skills are foundational across everything you're going to do, Jade, and regardless of which way you go, how they fuse together, because it's so seamless and STEM skills will never be redundant, you won't see the intersect between the two. So it'll blend together easier than you may think. Perfect. Anyone else have any quick things to add to Jade's question?
I think you hit the nail on the head. The IT resume is the perfect X to go along with your STEM degree, and the digital transformation into healthcare means that they're going to be really beneficial together. So I wish you all the best of luck, Jade.
Perfect. Well, thanks so much to all three of you for your time and for joining us. We look forward to following the rest of your careers. And that pretty much wraps up our webinar. So if you've been inspired after hearing from Michael, Lauren, and or Brett, make sure you check out more stories of Science Plus X careers in the latest issue of Careers with STEM. In these pages, you'll meet scientists working in diverse areas, from nuclear scientists who are using nuclear techniques to improve our world, to archaeologists investigating ancient artifacts, and virtual reality specialists bringing remote landscapes to life, plus conversationists turned tech specialists helping to save endangered species, and bioscientists improving the diagnosis and treatment of disease. You can find it all and more at careerswithstem.com. You can also head to careerswithstem.com to search careers and people by your favorite X, such as animals, business, creativity, crime, justice, and much, much more. And our next webinar will be on Wednesday, the 24th of May. And this one will be celebrating the release of the Term 2 edition of Careers with STEM, Maths and Data. Why maths and data? Because maths is the language of science and engineering, as all three of our panelists just touched on today. Whether you're working on developing new technology, conducting research, or solving problems in any field, you'll need a strong foundation in maths to be able to understand and work with complex concepts and solve problems. Make sure you register now, either through this QR code on the screen or on careerswithstem.com. And that brings us to a wrap for today. Thank you so much to our sponsor, QUT, and thanks so much to everyone here for attending our webinar. We wish you all the best with your STEM plus X career.